Let's do assignment 4, number 5. The cliff problem. Here's the cliff. Here's the ocean. Here's the ball thrown horizontally, following a projectile, hitting the ground. I mean the ocean. There's V final as an X component, V final X, a Y component, V final Y. Of course, we are remembering that Vx final equals Vx initial equals Vx. And since the ball is thrown horizontally, that's the initial launch velocity. We're remembering, as I always remind you, that Ax equals 0, and so the velocity in the x direction doesn't change. This means that Vy initial equals 0, and in order to find the time, we did this in lab, we used that delta y equals Vy initial t plus 1/2 ay t squared. I ran off the paper. Since V initial 0, that term goes to 0, and doing the algebra quickly, we get that t equals the square root of 2 delta y over ay. Skipping the math for time's sake, the answer is 3.16 seconds. Now with the time we can find V final, Vy final, and if we know Vy final and we know Vx initial, which is Vx, which is Vx final, we'll have the two components and we can get the magnitude and direction of the final velocity. How do we get Vy final? We just use equation 1, Vy final equals Vy initial plus ayt. Once again, the Vy initial is 0. So the Vy final is simply 9.8 meters per second squared times the time we just found, 3.16 seconds. That's equal to 30.92 meters per second. Without going through the rest of it, I'll just remind you that your magnitude of your V final, you're going to use the equation, remembering this, Vy initial squared plus Vy final squared. Give you the magnitude, and the direction, we use the familiar equation, inverse tan Vy over Vx.